In this video, we will discuss in question 3a part compute mean, median, mode, and standard deviation of a given small dataset. Explain when each measure is appropriate. Answer is a given small dataset D equals to 2, 4, 4, 5, 5, 7, 9. The mean, median, mode, and the standard deviation are computed. First, we will count the number of data item in this 1, 2, 3, 4, 5, 6, 7, 8. Hence 8 n equals to 8, and this is in a ordered data set. It is already a ordered data set. First, mean, that is average. It is a sum of all the value divided by the number of value. Hence 2 plus 4 plus 4 plus 4 plus 5 plus 7 plus 9 divided by total number n, that is 40 by 8 equals to 5. When appropriate, the mean is the most commonly used measure of symmetric normal distributed numeric data because it uses all values in a data set. It is suitable when outliers are not present or do not heavily skew the data. Medium, a middle value. A middle value of an ordered data set. Since n is even, it is the average of a two middle number, that is 4 and 5 values. The medium equals to 4 plus 5 divided by 2 equals to 4.5. When appropriate, the medium is preferred when a data is skewed or contain a specific outliers, as it is less effective by the extreme value than the mean. It is suitable for ordinal interval and a ratio level of measurement. Third, mode, most frequently value. The value that appear most often in this data set, the number 4, appear 3 times, which is more frequent than any other number. That is, the mode is 4. When appropriate, the mode is used when you need the most common value or category in a dataset. It is particularly useful for the categorical, nominal, or a discrete data where an average value may not be meaningful. A dataset can have one mode, multiple mode, or no mode. Standard deviation data spread. Uh, Calculation. Simple standard deviation, a measure of the average distance of each data point from a measure. Step 1. Calculate the variance sigma square by finding a square difference of each data point from a mean, assuming summing them and divided by n minus 1 for a sample. Difference from a mean 5 minus 3 minus 1 minus 1 minus 1 0 0 2 3. Square difference of this are 3 ka 9, 1 ka 1, minus 1 ka 1, minus 1 ka 1, then 2 ka 4 and 4 ka 16. Sum of our square differences is 9 plus 1 plus 1 plus 1 plus 0 plus 0 plus 4 plus 16 equals to 32. Variance sigma square equals to 32 divided by n minus 1 equals to 4.51. Take the square root of a variance. The standard deviation alpha equals to the square root of the variance, that is 2.14. When appropriate, standard deviation is used with a mean of a describes the variability or spread of a data across a center. It is appropriate for symmetric normal distributed numeric data and help understand how representative the mean is of a data set. What is the difference between error and artifact in data cleaning? Explain any two imputation technique. Answer. In data cleaning, error are original data acquisition issues that result in loss or incorrect information, while artifacts are the systematic problem introduced during data processing itself. Artifacts are often correctable, whereas original error usually result in permanent lost information. Error occur during data acquisition, entry, or initial collection. Examples: sensor failure, typos, power shortage during save, whereas artifact arises from the data processing or cleaning method. Applied example: an incorrect join operation, poor imputation strategies, or a bug in a transformation script. Recoverability. In error, the original true information uh, is fundamentally lost and cannot be recovered, whereas in artifact, a problem can be identified and corrected if the processing steps are re-evaluated or improved. The nature of error often random or tied to a specific unrepeatable event. Example: a single data entry mistake. Artifacts tend to be systematic and repeatable. Applying the same faculty process to similar data will produce the same artifact. The two imputation techniques are mean slash medium imputation. Replace the missing value with mean for normal data or medium for a screw data of that attribute. It is simple and fast and is useful for the numerical attributes. The second method is k nearest neighbor, KNN imputation. Identify k most similar record neighbors. It replaces the missing value with the average or the majority value of a neighbors. It works well when a data pattern are meaningful.